Welcome to your favorite pre-calculus course. Today we're going to talk about trigonometric functions of any angle. Your objectives, what we're going to look at is evaluating trig functions of any angle, using some reference angles to evaluate those, and then to, evaluate trig functions of any real number. So now, if you remember last section, we used the definition of trig functions, the right triangle definitions of trig functions, but they were restricted to acute angles. You remember how we had opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and so on for the sine, cosine, tangent, and then their reciprocals. Well, today we're going to, what if we expanded that and we still continue to use these right triangle trigonometry to do it? Well, if we get outside of an acute angle, what we have to do is use a reference angle to kind of jimmy rig it, okay? So you got these reference angles, which are the values of the trig functions where your theta is greater than 90 degrees, right? Is when you need to use these reference angles, and they could be determined from their values at the corresponding acute angles called the reference angles, and we call that theta prime. You see that little theta prime right there, that little mark up there. Now, the definition of a reference angle. So if you have a theta that's in standard position, okay, let me draw one here. Okay, and let's say we rotate. Now we got to rotate outside of that first quadrant, right? Because we're not an acute angle, or we already know what to do with acute angles. So let's say we rotate to here. Okay, so here's our theta that we rotated, right? So now, by definition, this reference angle, this theta prime, is formed by the terminal side of theta and the horizontal axis, okay? So what we're going to do is we're going to use this angle right here, theta prime, okay, in right triangle trigonometry to finish that off, okay? So it's that distance right here between the terminal side and the horizontal axis. Now what if we go, let's say we go into the third quadrant instead this time for theta, okay? Now the reference angle is going to be right in here, theta prime, okay? If we rotate, let's say we rotate into the fourth quadrant, okay, we rotate somewhere into the fourth quadrant, then the theta prime is going to be right there, okay, between that terminal side and the reference angle, okay? So let's go ahead and find some reference angles for the following examples here. Okay, so let's say our theta is 213 degrees, okay? So I always like to make these visual myself. So I say, okay, let's see, I've rotated 213 degrees, right? Here's my theta, 213 degrees. Okay, so my theta prime is right there. I say, well, how far past 180 degrees did I go, right? How far past 180 degrees? You say, well, 213 minus 180, that's going to give you what, 33 degrees? So theta prime here is going to be 33 degrees, right? Again, 213 minus 180, that's what's left over there. That's your theta prime. Okay, let's find a reference angle for, how about if we go 1.7 radians? Theta is just 1.7. Notice I have no degrees there. Here's your radians. So you're thinking, where in the world is 1.7 radians, right? I know where pi is. That's about 3.14 radians, 180 degrees, right? I know pi halves is 90 degrees. Pi halves is about what, 1.571, something like that. So we're just a little bit past pi halves. Just a little bit past that, right? And if you're not sure, you can always say, well, 1.7 radians, let's convert that to degrees, 180 over pi, and you get, I don't know, 90 something degrees. And then you know what you're rotating exactly, what quadrant you're going into, okay? But I'm confident here that we're a little bit into second quadrant, okay? So we've rotated 1.7, which means theta prime is going to be right here, Okay, theta prime is going to be right there. And I say, well, how much more do I need to get to 180 degrees? So if you were to figure this out, you'd say, well, 180 degrees minus that 97 degrees or whatever it is, and I'm going to just keep this in radians. So pi minus 1.7 is going to give you, let's see if I can find it, pi minus 1.7, 1.442. So it looks like theta prime is 1 point, what did I say, 442? 442 radians, okay? And in degrees, that would be 82.597 degrees, okay? 82.597 degrees. All right, let's do a negative rotation here. So how about, let's find the reference angle for negative 135 degrees, okay? So I rotate and I'm like, well, there's negative 90 degrees to that spot right there. How much more do I got to go? About 45 more right there. Okay, so here's theta being negative 135 degrees. My theta prime is going to be right here, isn't it? It's between the terminal side and that horizontal axis. Well, how much more do I need right there to make it to all the way negative 180 degrees, right? How much more do I need? Well, 180 minus 135. So like that's what, 45 degrees? You know, how much more do I need? 45 degrees. There's my theta prime, right? So theta prime there's 45 degrees. Okay.